Hi, I'm Garima, as he mentioned, and this is the title of my talk, Dagger to Android, Defeat the Dahaka. So, I'm from Delhi, India, and I'm an Android developer, and I'm also a technical speaker, and so far I have spoken at droidCon India, droidCon Boston. And I work at Fueled, which is a service-based company. And we have worked with clients such as these. Some are QuizUp, Afterlight, Barney's New York, and so on. And in the past, we have worked with some of these technologies. And one of these technologies is Dagger, Dagger 2, that is. And that is why I'm giving this talk. So sometime this year, sometime back, Dagger 2 Android was introduced. And I've been experimenting with it a little bit. And I would like to share my findings with you all. So firstly, I would like to go with the pop quiz. How many of you have used Dagger 2 in your apps? Great, many of you. Next is, how many of you have heard or experimented a little bit with Dagger 2 Android or used it in your apps? OK, half of you, great. And how many of you have played or heard about Prince of Persia? Oh, that's great, so many of you. Glad to hear that. So I am going to use a little bit of analogy. I'll try to explain that analogy to you guys. So the theme of this talk is Prince of Persia. So the story here is that there's a prince who uses dagger. Dagger can reverse time. It is a weapon which can reverse time. And Dahaka, there is an enemy who is the guardian of the timeline. So if anybody would meddle with the timeline, Dahaka will come to kill that person or someone it is. So Dahaka comes to kill the prince. This is the story of Prince of Persia. And here is the analogy. So the prince is us developers. And Dagger is Dagger. And Dahaka enemy is the code complexity that comes with the generated code. So when you start writing Dagger, you start with an app module, app component. And as and when you go on further, there are a lot of generated classes. And when you try to go through those classes, there's a point when you feel that it is a bit overwhelming to see and go through the code. And there are a lot of annotations and everything. So I'm going to try to explain these things to make it a little bit easier. And we're going to try to defeat Dahaka. And we are also going to try to befriend the beast. So as I mentioned, we all developers, we use Dagger. And developer starts backtracking the generating code. And developer is chased by the Dahaka, which is the complexity of the generated code. So this is the agenda for this talk. Firstly, I'm going to give a brief introduction of the Dagger and how it came. And then I'm going to deal with scopes. That is what I like to call the face of the Dahaka. I'm going to go into the singleton scope, the reusable scope, and maybe a little bit of custom scopes. And then I'm going to try to explain a little bit about component dependencies. That is, I'll do it via a demo app, which is going to be a Pokemon app. So we're going to try to defeat the Dahaka using cute Pokemons. And then I'm going to look at the dependent component. And then I'll try to explain subcomponent and the difference between the dependent component and subcomponent. And then I'm going to touch upon a little bit of intermediate concepts that comes around, not with just Dagger Android, but also if you're not using Dagger Android. Finally, I'll try to go over Dagger Android and how we can implement it. So we're going to try to befriend the beast in the end. So who is this talk for? Assumption here is you have at least a basic familiarity. You might have implemented at least the basic level of the test code of Dagger. And if you have intermediate level in Dagger, then this is the talk for you. So let's start with the first part of the talk. It is called introduction codes of time. Once upon a time, there was a droid of Asia. He used to write code like this. He used to instantiate his services within his class. The disadvantages of using this approach when you instantiate any dependency within your class is the code is not testable. You cannot swap out any dependency. You cannot swap it out for test, or the code is not even extendable, because in the future, if something changes, you cannot change your dependencies because they're all over the place. If you change it one place, you'll need to go back and change it at many places. So then comes Dagger 1. Dagger 1 had its advantages also. The code became testable. The code became much more modularized. However, there were some disadvantages of Dagger 1 also. For example, Dagger 1 used reflection, and the graph composition was at runtime, which made it a little slow. And because we didn't have that much custom scope thing in Dagger 1, so we used to result into a God module. I'm going to talk about it. And it was difficult to use ProGuard because there was reflection. Then came Dagger 2. Dagger 2 has its advantages. There is no reflection being used in Dagger 2. And the graph is generated at compile time. So it is faster in comparison to Dagger 1. And the code is traceable. The best thing about this is that the code is traceable. In Dagger 1, you could not go through the code generated classes and test, trace what is actually going around. It was all magic, it was behind the scenes. Now you can actually see what is going on. And with Dagger 2, we have better scope management. Speaking about scope management, it brings us to the second part of our presentation. That is the face of the Dahaka. Let's look at scopes now. So what is scope? Scope is an annotation from javax.inject package. Sometime before Dagger 1 came out, there was this standardization JSR 330, which standardized various dependency injection frameworks. Earlier, people used to use Juice, and somebody was using something else. So they standardized it into javax.inject package, and that is where scope is from. So it just doesn't apply to Dagger. It applies to dependency injection frameworks in general. So scope is how long a particular instance lives in the lifetime of your application or anything. So what happens if no scope is specified? If you do not specify any scope over your component, then every time you get that dependency, a new instance for that dependency will be created. Your provider methods, those will get called whenever you will try to get that dependency. But if you specify an annotation, there is a possibility that your dependency might get reused. It is not mandatory that even in this case, the dependency will get reused. We'll talk about it, how that will happen. So firstly, we'll visit the singleton scope. As you all know, this is another annotation from the javax.inject package. So this is also a general standard, this singleton annotation. And this scope of dependency is, the scope of this dependency is throughout your application. Your dependency will be living through the whole lifetime of your application. So there are two ways to reuse dependencies. Firstly, you can annotate the provider methods. That is, your methods in the module class, you can annotate those methods with your annotation singleton. And the second way is you can annotate the dependency class itself. On the top of the class, you can write the annotation, and you can reuse it then. So let's look at an example of singleton. So this is your app component. We are marking it as singleton. The first case is dependency without any scope. So if you see here, we are providing the application, but we have not specified the scope. @singleton is not written over here. So in this case, this is the Dagger app component that gets generated for your app component. This is the component that Dagger generates for us. So first thing to note here is, for every dependency, Dagger generates a provider or a factory class for you. So in this case, it has generated an application provider. That is the provider. This provider of something is also a standard interface from the javax.inject package. And your application provider is getting initialized using a factory. So if you see, in this case, the factory that is creating your dependency is same as your provider. We'll see how it is going to be different in other cases shortly. So in this case, whenever you will try to get any dependency, it is going to call the factory.get method, and it is going to every time instantiate new class for you. But yeah, with application, it doesn't make sense, but it is just an example. If you use it with some other dependency, you'll see that the dependency is going to be instantiated again. So the next case is dependency with scope. What happens if we do specify scope? So this is your app module again. Notice that we have specified @singleton in this case. And this time, Dagger app component that gets generated is, we have this something called as double-check.provider that Dagger is encapsulating our factory, the factory which we had earlier. Now it's encapsulated in this double check. So what is this double check? Earlier, we had factory, and the provider was equal to our factory. Now, in this case, our provider is double check provider, and the factory is simple. So let's look at double check. So we got visited by Dahaka a bit. So what is double check? Double check is something, a class from the Dagger or internal package. It memoizes value using double check idiom. So when I was going through the documentation, I came upon this memoizes term, and if you are just like I am, I thought it was a spelling mistake, but memoizes is something which stores. So in this case, it is called that the dependency will get stored. It will get memorized. So this is the source code. So as the name suggests, double check. There is going to be double checks. Like the first check is there. So double check is a common idiom which is specified in the effective Java book. If you want to know more about it, you can read about that. So the thing to note here is, there is a double check logging. We check for the instance first, and then we check for the instance again. And the point here is, we should not scope all the things, because scoping has its overheads. Like if there is something which is not so heavy, you should not scope it. Like you should not go around scoping each and every method in your module. You should use the scoping, because you should use the scoping only when it's required, because it has its overhead. Whenever, like in this case, if the object was not heavy and you used scoping, then every time we'll try to get that dependency, there will be a double check that will happen. So we don't need that. We should by default use no scope, and we should scope only when it's needed. Like for heavy mutable objects. So why I say mutable objects here? Because mutable objects are those which have some kind of state. So in this case, like when an object is needed only once, like only one instance has to be created throughout your application, then we should scope it. So next, let's look at the reusable scope. What is reusable scope? So reusable limits the instantiation, but it is a little bit different from singleton scope. When we want to use exam same instance, then this is not the scope we are going to use. Then in that case, we should use singleton. Reusable is something that should be used when there is something heavy, but it's not necessary that only one instance is need to be created throughout your application. And also, this reusable scope, it is not tied to any component or subcomponent. You can go ahead and mark your provider methods as reusable, even it is a component, or even if it is a subcomponent. You can go ahead and mark it. Like, For the other scope annotations, you have to mark your component with that annotation, and then you have to mark your provider methods. But that is not the case with reusable. You can go ahead and use it with any provider methods and any component or subcomponent. Reusable, the thing to note with reusable is reusable can have multiple subcomponents caching the value. So what can happen is, for example, a dependency which was needed, it is getting used for the first time in some subcomponent. So that subcomponent is responsible for caching that dependency. And because if there is some other subcomponent that doesn't know about that dependency, so that subcomponent is going to cache this value again. So we might end up with multiple instances of the same dependency. So that is why this reusable, it can have multiple, that is how it can have multiple instances of the same activity. So what we should use it for is, we should use it for heavy immutable objects. For example, so that even if the state of that particular object gets changed, it shouldn't affect the whole application. So let's see how we can use reusable. For example, there is this any component. I've just named it reusable component, but you can name it anything. So you have this dependency, which is a some object, which is any object. You can annotate this dependency on the top of the class, and that is how you can mark it reusable. So this is what Dagger is going to generate for us in this case. You can see that we have the same thing. We have the provider of that dependency. And Dagger, in this case, instead of double check, it is only introducing single check. So this is what single check is. Instead of double locking, it memorizes the value using simple lazy injection and caching. So this is the code. You can see that there is only a single check, as the name suggests. So what is the difference between singleton and reusable? As I already mentioned, if you have a heavy mutable object, then mark it singleton. Remember that if the object is mutable, the state can get changed, then singleton. And if it is heavy, but it is immutable, you cannot change the state, then mark it reusable. So everything is fine. So far, everything is working fine. But with this approach, with singleton and everything, we might end up with the God app module. And how can that happen? Let's see. You have a simple app component and app module. You add some more dependencies to it. Your app module keeps on growing. And it grows furthermore. So this is when you end up with the God module. Like everything you are keeping in your app module only. Everything is singleton. But you might want some kind of custom scoping. Yeah, you might want that some of the dependencies should live for a shorter period. Like you might want that your presenter should live only in the activity scope. It should get destroyed. If you want that, like custom scopes then, like that, what you can do is you can use custom scopes. But for improving the God app module, there is another way. Firstly, let's look at this a simpler way, which is splitting the app module. You had this God app module. What you can do is you can firstly split the app module into app module and API module. So all your API module API dependent dependencies will go into the API module, and rest of the dependencies will go into the app module. And how you can do this? You can simply, within the @component annotation, you can specify both the modules, app module, API module, or you can also include that, you can use the includes and include that particular API module into the app module. So in both these cases, what Dagger is going to do, it is going to keep an instance to both your app module and an API module. Earlier, it was keeping an instance to only the app module. So this is done. We are happy, but as I mentioned, there is no custom scoping over here. So we also need to specify some kind of custom scoping. And we also need much more modularity, because currently there is only one module and all our dependencies, one module, or you can say two modules, but still the scope of those dependencies is still singleton. We need custom scopes like user scope maybe, that the dependencies are only surviving. For example, your user object, it needs to survive only when the user is logged in. Or the activity scope. Some dependencies might need to survive only when the activity is active. And like fragment scope. So how can we do all this? So whenever you want to create a custom scope, you need to create a new component. And that is when you end up with multiple components in your app. And with multiple components, there are two ways of doing this. You can either create a dependent component, or you can create a sub-component. So some time back, I was like using only dependent components in my app. And when Dagger Android came out, I just wondered, like, I don't even know what sub-component is. I should go and check what sub-components are. So that is when I got into it, and I started experimented with it, and that is what I'm going to share. So next topic of our presentation is the component dependencies. Like, what is this dependent component and sub-component? We're going to try to differentiate between these things, and we're going to try how Dagger internally, like how generated code looks like with all these things. So we're going to do this using this Pokemon app. So this is the scoping architecture of our Pokemon app. Firstly, there is app component which has a singleton scope. All these dependencies in the app component will survive throughout the application. Then there is user scope. And also then there is activity scope, and then there is fragment scope as well. So firstly, we launch the app. That is when your login activity will come. And this login activity is going to have activity scope. We are going to log in with the user, which has the user ID called Pikachu. And when we log in with this user, the user scope is going to start. So we are going to provide this user, which is called Pikachu, in this scope. And we're going to use it throughout the application, like whenever the user is logged in. So the next here is, like, we can visit the inventory of that Pokemon. And when we will log out, this user scope is going to end. Then we'll log in again with some other user, and so on. We can visit the inventory. So let's look at the example. So firstly, we are logging in. So this is the login activity, and this is when the user scope starts. This is all in the user scope. We are visiting different fragments. They have their own scope, fragment scope. And then we are visiting the inventory now. This is a different activity, which has got activity scope. And then we are just logging out. And then we can log in with some other users, and the scope will end. So let's come to the differentiation, and let's try to look at the code and also the generated code, and let's try to solve this problem. So this is what we are going to create. So there's going to be an app component, which is going to be a singleton interface. It is going to expose the scheduler provider. And then there is going to be an implementation of app component, which the Dagger is going to generate for us. And this implementation of app component, if you see, it is going to have a login subcomponent, which is the login component IMPL, which is the implementation of the login component. If you notice here, login component is going to live inside the implementation of the app component. So this is what is a subcomponent. And next is the user component. This is the implementation of user component, which is, again, Dagger is going to generate this for us. It has further more subcomponents like home component and items component. And this component, it needs a dependency called scheduler provider, which is provided by app module. So it is going to get and use it from there. So let's see how we can do this. Firstly, this is our app component. We're going to mark it as singleton as usual. And then we're going to expose this dependency. We'll see, why do we need to expose this dependency? Let's look at the application class. What needs to be done is we just need to create this Dagger app component over here. And let's look at the user component. So what I have done is I have made the user component as a dependent component, and there is going to be a login subcomponent. There's going to be a subcomponent of the app component. So this is the user component. So how can we mark a component as a dependent component? We're going to write this term, dependencies is equal to this. So this is how we make user component dependent upon the app component. And we're going to mark it as a user scope. This is fine. So as I mentioned, in this case, Pokemon is the user. So how can we provide Pokemon in this case? There are two ways of providing Pokemon in this case. The first way is using the normal way that we do. We use the user module. Like we are in the user component, we're going to use the user module, and we're going to provide this Pokemon using the constructor of user module. Or we can use the @component.builder with the bind instance. We'll see what that is. So first way of doing this is we can pass in the Pokemon, that is our user, to the module, and then provide it ourselves. This is the first way of doing this. Or we can tell Dagger that this is the builder. This is the builder class that you need to create. We can tell the Dagger using @component.builder. This will tell Dagger that create this builder for me using this particular interface. So this is where we'll tell the Dagger that we need to bind this instance, or we need to bind this instance into the graph. We need to bind the Pokemon instance into the graph. So we do not, if you see, we do not have to now provide, instantiate, say, make our module stateful and keep the state of Pokemon inside our user module. We can just tell Dagger to do this, and Dagger will bind this particular dependency into the graph. So next, look at the user manager. User manager is a singleton class. And inside user manager, you see we're creating the user component. We are using the builder that we just created. And inside that builder, we are passing in the Pokemon dependency. So whenever the person is going to log in, we're going to call this method called create user session. And in that, we'll get the Pokemon from server, and we'll instantiate this particular user component at that time. So what gets generated in this case? Let's see. So again, we needed that scheduler provider. So we have an instance of scheduler provider, which Dagger keeps. This scheduler provider, if you see, we need to get the scheduler, and this Dagger is creating the scheduler provider, and it needs the app component instance. So this scheduler provider, whenever any dependency which is inside the user component, whenever it will need the scheduler, it is going to get that scheduler provider from app component instance. So that is why it needs to store that app component. So if you remember that this user component, it is a dependent component on app component. So that is why it needs app component while instantiating itself. And it doesn't know about the implementation. The Dagger is going to generate Dagger app component. This user component doesn't know about that implementation. What it knows about is the app component interface. That is why we need to expose this particular dependency in the app component. We again got bit by a Dahaka a bit. So next, let's look at the subcomponents. So as I mentioned, we're going to now create a login subcomponent, which is going to be a subcomponent of the app component. Login subcomponent. How we can do this? Firstly, this login component is going to live only inside the login activity. So we're marking it with the activity scope. And this is how we tell Dagger that this is the subcomponent. We mark it with @subcomponent, and we pass in the module, whichever is for this subcomponent. And just like component.builder, in this case, we have subcomponent.builder, and in this case, we're going to bind the instance of activity. Earlier, we bound the instance for Pokemon, and in this case, we want to provide activity, so we'll just tell Dagger that bind this login activity to the graph, and whenever we'll need that activity, we can just go ahead and inject that activity and use it. So what do we need to write in login activity? So we're going to create the subcomponent in the login activity. So from the app component, we're going to get the login builder, and we're going to pass in the instance of this, that is the login activity, and we're going to create the login component. So this is how login component gets created. So let's look at what Dagger will do in this case. So this is the generated class for Dagger app component. And this is what is going to get generated. So we have a factory of login component builder, and we are creating the login component builder. Login component builder, it is implementing the builder that we specified in the login component interface. And if you see, in this case, the login component IMPL, it is implementing the login component. So in this case, login component IMPL gets created, which is an inner class. That is why anything which needs to use any dependency of login component, it can go ahead and use it because it is an inner class. Whereas the Dagger component, Dagger user component, it is totally different. And if that one needs any dependency, it is going to use it via interface. And it doesn't, it can just go ahead and use any dependency it needs. So we again got hit by Dahaka, but so this is, let's look at what is the difference now. So we have Dagger app component. It is just the same thing. Login component IMPL gets generated, which is an inner class of Dagger component. And then we have user component, and it can get the scheduler provider from the app component interface. So there are a few advantages with custom scopes, dependency lifecycle management, modularized code. And there are still some limitations. That is, the inject code that we're writing, it becomes repetitive. And the class, it knows about its injector. For example, in login activity, it knew the app component is the injector, and so on. So to simplify all these things, Dagger to Android came. First, let's look at the intermediate concepts related to Dagger to Android. These concepts are not just related to Dagger to Android. And these concepts can also be applied when you're not using Dagger to Android. So firstly is the @binds. First is the @binds annotation. What does @binds annotation do? If you have an app module, and if you have any kind of module method which is providing a scheduler, and the return type can be easily assigned to whatever dependency you're providing. So what you can do is, in this case, is you can just create mark the module as abstract. So Dagger is not going to create an instance of this module for you, and it is just going to use the provider classes which it anyway creates. So this also optimizes your code. So next we have multi-binding. Multi-binding we'll look at an example for this. There is an annotation called into set. What is this? So if you have 3 strings that you need to provide hello, you need to provide hi, you need to provide how are you. So what you can do is, you can just mark these dependencies into set. Otherwise, you would have to create qualifiers for these and create these dependencies separately. So you can just mark it into set, and what Dagger will do is, it will take all these dependencies and it will provide a set for your instance. So for these 3 dependencies, then you can just go ahead and inject this set instead of those particular dependencies separately. So next is the into map annotation. So let's look at an example for this. If you have a presenter and you have multiple dependencies for it, you have the map presenter, you have just presenter, and so on. So in this case, what you can do is, you can instead mark it as into map. And you can give the keys that this key is bound with this. So what will happen in this case is, you will be able to provide it. You will be able to provide different presenter methods, different presenters using this provides into map. So let's briefly look at, I guess I'm running out of time, so let's briefly look at the Dagger to Android. So we have the application class. We have something called has activity injector. We implement it. We need to inject the dispatching Android injector. And we need to return the same instance. So what is has activity injector? It is an Android injector of activity. It is a simple interface which says that this class, whoever is implementing, has an activity injector. So what is activity injector? There's a class in a Dagger called Android injector. It is an Android injector of activity. So we have a has activity injector, which is implemented by our Dagger application. And this Android injector, it has an instance called dispatching Android injector. It implements the Android injector. So this is the hierarchy in this case. What is dispatching Android injector? It injects members for Android types, like activities and fragments. It has something called as injector factories. So this is the map that it has. We just talked about into map, right? This is how we're going to inject a map of the class to the subcomponent builder. So what it will do is it will get that subcomponent builder, and it will create an instance using that builder, and it will call .inject on that particular instance. So this is the whole maps that are going to get created for our application. So how we can implement this? We are going to add app binding module and Android support injection class. These are the two new modules that we are going to add. So what is app binding module? Here we specify @contributes Android injector. And what is contribute Android injector? If your module is stateless, then if your subcomponent builder, it is something simple. It doesn't bind anything extra, like if it just binds the activity only or the fragment only. Then you can specify @component injector, and Dagger will generate that subcomponent for you. So in our case, we won't have to generate the login activity subcomponent. So this is the login module. Sorry. Just a second. So this is the login module, and as you can see, it is stateless. So what we can do is we can mark it as @contributes Android injector, and this is the login binding module that Dagger is going to generate for us. So it is going to mark that it is going to generate a subcomponent for us, and it is going to mark the subcomponents as login activity subcomponent. And it is going to bind the login activity.class with our subcomponent builder. So this is marking our activity subcomponent as the subcomponent of app component. So this is the app component again. And we have something called as Android support injection module. I'm just going to skip through this one. Then we have our login activity. Let's see how we can implement it. What we need to write, earlier we used to write all the injection code. Now we just need to write Android injection.inject. This is all. And what is Android injection.inject? Well, if you go into the generated classes, the Dahaka is going to bite you. So let's try to befriend the beast here. So we have this login activity. We can get the application from this. When we get the application, we can get the activity injector, which is the has activity injector. And we can call .inject on it. I mean, not we. Dagger is going to do this for us. And the factories that I talked about, it is going to get the factory. That is a subcomponent for that particular class. And then it is going to get the build method. The factory was actually the subcomponent. So it is going to call the build method on that subcomponent, and that is when the component will get created, and it is going to inject the activity on it. So there are some Dagger boilerplate classes which simplify all this has activity injector, and you can go ahead and read about it. Let's briefly look at how we can test with Dagger. So we can inject the presenter. Sorry. This is the presenter that we need to inject. And we're going to provide a mock implementation of this presenter using the testing. So this is what we're going to do. We're going to mock the login presenter, and we're going to provide a mocked implementation of this. If you want to go into the implementation, you can find the Dagger code on my GitHub. That is rackdroid Dahaka. And it has got various branches which explain Dagger, Dagger Android, dependent component, subcomponent, etc. So finally, Dagger to Android is Dahaka. So what we need to do is we need to befriend the Dahaka in order to understand things. So it will not only make us understand, it will also make us optimize our code better, and also make us able to test the code better. So as I mentioned, you cannot change your fate, no droid can. So let's befriend the beast. Let's use the Dagger, the complexity of Dagger and the Dahaka to our own benefit, and let's try to befriend it. So I would like to give some acknowledgements. There is a very good blog by Miroslav, and he has written a lot of recipes for Dagger. And there is recently by Mike, he has migrated to Dagger Android, the to-do application. And you can also look at the Android dialogues from Mike, which explains how we can optimize Dagger and how to use Dagger better. And some proofreading and migration to Kotlin was, I was helped by these people. So what is next? Read the Dagger documentation. Check out the migration branch to do MVP Dagger from Mike. Look at the Dagger example on my GitHub. You can also look at the testing articles to go ahead and befriend the beast and be able to test more. And you can also look out for the Dagger and the Dahaka series that I've been writing on Medium. I'll be posting more posts on this. And some other references of the pictures where I have taken. And here is some cut scenes that I did not add into my presentation because they were too much. And finally, thank you.
Thank you, Garima. Nobody's going to be afraid of the beast anymore. Are there any questions to Garima? Oh, it looks like everybody's too hungry to ask for asking questions. Yes, please, come to the microphone.
If there is any difference between the reusable scope and no scope?
Sorry, between?
The reusable scope and no scope.
Yes. In the case of reusable, it is going to, as I mentioned, it is going to wrap it with single check. In case of no scope, it is like every time either the provider method is going to get called. But in the case of reusable scope, if the dependency has been injected once, there is like a lot of chances that that dependency is not going to get instantiated again in the case of reusable, but it still might get instantiated. But whereas in the case of no scope, it is always going to get instantiated. I hope that.
But actually, the reusable scope seemed for me as a singleton, because we created
one. Yes, it seems to be singleton, but if you just imagine, if you're using it, if there is a subcomponent, and if there is another subcomponent, and you mark a particular dependency, which for the first time gets injected in one subcomponent, then that particular subcomponent is going to be responsible for caching it. And then if there is another subcomponent, that other subcomponent is not going to know that any dependency got created. So that subcomponent is going to again instantiate this dependency and cache it for itself. So in this case, it might, there is a reason. So that is why I mentioned that you should use it for heavy objects, but those objects should be immutable, because there is a chance that they might get instantiated more than once.
Okay, thank you.